Hey, what's up everyone? Welcome to this tutorial where we are going to see how to build your first Swift UI app from scratch. So this is a beginner tutorial, meaning that I'm not going to assume you are familiar with iOS, UIKit or SwiftUI. However, I'm going to assume that you have some computer science knowledge, meaning that you have some knowledge with a programming language that is quite recent and quite similar to Swift. What else should I say before we get started? If you're watching the tutorial live, remember that you have a chat where you can ask questions and I will try to answer them as best as I can. And I see a few messages in the chat. So let me say hello to Adele and to Frin. And I think that's all I wanted to say for the intro. So let's get started. As you can see on my screen, I have opened Xcode. So what do you do when you want to build your first SwiftUI app? You create a new project on Xcode. And when you create a new project, you get this window where you need to select what kind of a project you want to create. So we're going to go for the most simple one. So as you can see, I've selected iOS because I will only cover iOS in this tutorial. And I'm selecting app, which is your most simple kind of app. You're just going to create a project with a simple screen and we will build from it. Then we click on next. We need to give a name to our project. So I'm going to call it first Swift UI app, like that. So you want to make sure that for the interface language or the language for the UI of your app, you do select Swift UI. For the language, it's a drop-down, but you don't have a choice. It's only Swift that you can choose when you have selected Swift UI. And I will leave use core data and include test unchecked, just so you know. Core data is what you use when you want to save complex data to the phone, and tests are well to test your app, but I will not cover them in this video. Then you click on next. You need to choose where you want to store your project. So I'm just going to store it on my desktop. It's going to create my project in Xcode, and this is what you get when you create your first SwiftUI project in Xcode. So first, let's go over all the files we have in the project. So from the top, we have this, which is the Xcode project file. So this is basically where you have all the configuration of how your project will be compiled, executed, etc. I won't go over it into too much detail because it's a big topic of its own, and it's really more, we could say, an Xcode thing than a pure SwiftUI thing. And in this tutorial, I want to focus on pure SwiftUI things. So then we have two Swift files that have been created. The first one is called first SwiftUI app. So it's the name of the project and then app at the end. And inside we have what is basically the entry point of your app, meaning the code that will be called by iOS when your app is opened. So you can see the entry point because we have a struct that is annotated with @main. This struct is called first SwiftUI app. So I see how stupid that name was, but we're going to bear with it. It conforms to a protocol called app, and it has a body which returns some kind of scene. And here the scene is something called a window group. So it's basically what you use to contain the views that your app is going to define. And inside that window group, we have a content view. And so the content view is the second file that was created for us. So it's the screen. So you can see a preview of that screen. Let me make it so that we can see the entire screen. And you can see this content view is also a struct that conforms to the protocol view. This struct also has a body, but this time it's not some scene, it's some view. And inside the body, we have the content of the screen. So we have a VStack. We'll see a bit later what it is. But what you can see is that in this VStack, we're displaying two things, an image and some text. And you can see the image and the text being displayed in the preview. We have this little thing called a modifier. We'll see later what it is, but it adds, we could say, some layout logic around the VStack. So by adding some padding, so some margins on the side of the VStack. And finally, we have another struct called content view underscore previews, and this is what generates this preview right here. So this struct conforms to yet a third protocol called preview provider, and this one doesn't have a body, it has some previews, and in that preview we just have the content view. So let me take a look at the questions in the chat. So I see a question, let me display it so that people can see it when they watch the replay. So content view is the first screen of the app. Absolutely, absolutely. The first and the only screen of the app right now. Actually, I'm going to run the app in the simulator. So I'm going to take an iPhone 14 simulator and launch the app in the simulator. It's going to take a few seconds for the simulator to boot. I just want to show you what it looks like when you launch the app, but of course, as you've probably already guessed, it's going to look exactly like the preview because, as we've seen, the app displays the content view, and the content view looks like this. So let me see, is the simulator ready? It's booting up. Okay. So I'm going to put it next to the preview. So I see a question, will I save the stream on the channel? Yes, as soon as the live is over, the stream will be available as a replay on the channel, and you will even have a link in the description to a GitHub repo with all the code I'm going to write during the live. Okay, as you can see, this is what the app looks like. So of course, now we want to implement a real app that does a bit more than just displaying some static image and some static text. So I had to decide what I wanted to implement in this tutorial. Of course, I killed the app, and so it stopped executing. And I decided I wanted to implement a simple app that fetches data from an API. So I had to choose an API, and I decided to use the API that I've used actually in quite a lot of my videos, which is the movie database. So it's an API that gives you data about movies and TV shows. It's probable that if you've already used a media center app to watch movies on your TV, actually that app was using this API to display the nice, beautiful covers of the movies. And so we're going to implement an app that fetches a list of movies, displays them in a list, and then can also display a detailed view with the credits of the movie. So meaning the cast members, the name of the actors, and the name of their characters. But we're going to do it step by step so that we can really understand how you build such a simple app, but that is still a bit of a challenge when you are discovering SwiftUI for the first time. So first thing we're going to do, I have a little paper with the outline for this live. We're going to implement a view that displays a list of movies with something that's called mocked data, meaning data that is hard-coded in the project. So we're not going to begin by fetching data from the API. First, we're going to use hard-coded data, focus on the UI, and then we'll move on to implementing the actual network call. So first thing I need to do is to implement the model for the data I'm going to display. So I'm going to create a new file for it. It's a good practice to create a new file whenever you want to introduce a new concept to your project. So you do either file, the menu file, new file, or Command N like I just did. And I'm going to select a new Swift file. I will call it movie. So you see the file has been added. And inside of it, I'm going to define a struct, so a data type, that will represent my movie. So of course, on another screen, I have the finished version of the project that I can look at when I have a doubt or anything. So I'm just opening the movie on that second screen, so I make sure that I'm not making any mistake. So what kind of fields do I want to have in this struct? I want to have actually, I'm going to implement the same field I will have when I will get data from the API later on so that we can win some time. So I will have an ID, and we will see this ID is important when we want to display a list of data. Then we will have the title of the movie. So I'm going to implement it as a string, which stands for string of characters. So basically some text. Then I'm going to have an overview of the movie, which is also going to be some string. And finally, since I want to make an app that looks kind of nice, I want to also display the poster of the movie. And for that, the API will give me something that's called the poster path. So it's the end of the URL that will give me the image with the poster of the movie. So that path is a string, and we will see later how do I turn that path into an actual URL. And finally, if I want to have some hard-coded data, I need to implement some hard-coded data. And so I'm going to copy-paste my data. So you can see I've implemented an extension of movie. So extension, it's a way in Swift to be able to add some additional behavior or static data to a type. And so here I'm adding a static property called mock. So we'll be able to call that property on the type itself. And it's returning a movie that is hard-coded inside my project. So that movie is Jurassic World Dominion. And you can see I have the title, the overview, and the poster path. And with this, I have some data, and so I can use it to start implementing some UI. But first, let me take a look at the chat. So I'm seeing a question that says, can you show us how to understand the MovieDB API? That way we can navigate different APIs. So I will show you later how to make the network call during this live. And also I have planned later this month a video to be focused on writing your first API call that will go into that into even more details. So we have the mock data. Now let's go back to the UI. I see a question that says, if ID is not defined in the JSON, we must write it or not. I will cover this. I will cover this when I start implementing the list, and we will see if it's needed or not. So let me move the movie just a little bit above, and let's go into the content view. So I'm going to rework this content view so that it displays first the data about my movie, so Jurassic World Dominion. Before I do, I see another question in the chat, which is amazing because it makes this live feel so alive. So the question is, how do we decide if something is declared inside the struct definition or as an extension to it? That is an excellent question, and like all excellent questions, the answer is often, not it depends, but there is some leeway on it, but I would say in the type itself, so the struct, it could be also a class, you put what is necessary to implement the type, and in the extension, you put all the auxiliary things, meaning that you could remove the extension and the type would still function. So here I chose to put the static var mock inside an extension. I could have very well put it in the type itself, but I think it's better to put it in an extension. This way, when you open the file, it conveys very clearly that this is what a movie is. This is the core part of it. This is like, if you want to understand what a movie is inside the context of this app, this is what you should focus on. And then this is some accessory thing that you can use if you want. Also, I'm not going to show it because it's a little bit more complex, but you could use something like conditional compilation. So it's a bit more of an advanced topic, but I want to answer the question thoroughly. Something like this, where you would say, this extension only builds if I am in debug mode, but not when I am shipping to the App Store. So that's another added advantage of implementing things inside an extension. Also, you could put it in a different file with all the mock data. I hope it answered your question. Going back to the view, so I said I want to display now the data of my movie. So first, if I want my content view to display data about a movie, maybe if I want to first start by renaming it, for instance. Naming it movie view would be much more relevant. So to rename the view, I can do a command click on it, and I can choose rename. And this way, Xcode is going to open an assistant that will allow me to rename the view across all the occurrences it has in the project. So I'm going to rename the content view movie view, and you can see that the usage of the content view inside the app file is also being renamed at the same time. So is the name of the file. When I'm done, I press enter. You can see it didn't rename everything. Here, I still need to rename content view to movie view. That's because this is a symbol that has actually no link with movie view in the eyes of the compiler. All right, the change has been made. And so now that I have a movie view, that movie view needs to have some movie that it will operate on. So since movie view is a struct, I can add some fields to it. So here I'm adding a let property called movie. So let means that this property will be initialized when I create the struct, but it cannot be changed after the fact. If I wanted to make it changeable, I will need to make it a var and maybe even more, but we will cover this just after. For now, let's keep things simple. You give it a value when you init the struct, and that's it. That value doesn't change. So you can see as soon as I've made that change, I have a compilation error in my preview because I am missing the argument for the parameter movie. So let's add that argument. And what value do I pass for the movie? I'm going to pass my mock movie. So I do it by calling the static property on the type movie, like that. I can actually even omit the name of the type because the compiler is able to infer it. I'm just going to leave it for now so that it's very clear, but later for the next occurrence, I will no longer be mentioning the type. And so now I can use the movie inside the body. So I'm going to remove everything inside the body so that I can really build it from scratch. First thing I want to display is actually the title of the movie, which means I want to display some text. And when you want to display text in a SwiftUI app, you use a built-in view called text. This view takes an argument, which is a text that you want to display. And so here it's the title of my movie. Let me save. You can see that the preview is reloading. And you can see there is an error, failed to build the preview. And the reason is that you can see here that there is still one compilation error in my project, and it's inside my app right here, because here I need to also provide the movie. So I'm going to do the same thing than in the preview. And with that change made, my preview should now be able to render. So let's give it a few seconds, and you can see that I have the title of the movie being displayed. Okay. I'm also displaying the finished version, so I make sure I'm not forgetting anything. All right, perfect. Then below that, I want to display the overview of the movie. I'm going to do it in a naive way that of course won't work, but I want to show you what's the result when you make that mistake. So I'm going to add a second text that will display the overview of the movie. You can see that nothing has changed in the preview, but there is a second movie view that's appearing right here. And when I click on it, this time I have the overview, which is super weird. And the reason is that I have actually two views in my body when I shouldn't have two views just like that. I should have something that says how they should be displayed relatively to one another. And so this is where the vstack that we saw in the code that was generated by default comes into play. Vstack and its other, its browser type, we could say hstack, are two views that allow us to display view together, either stacked vertically or stacked horizontally. So here I want to use a vstack, and the way I can do it is do a command click on the first text and choose embed in vstack, and then I just cut and paste the second text inside the vstack. And you can see that now the two are displaying one on top of the other. You can also notice that the views are being displayed from the center of the screen. This is SwiftUI default behavior, and this is one of the biggest difference with UIKit, where things would start on the top left corner of the screen. So we have our two pieces of text displayed on the screen. Of course, when you look at how it looks, it doesn't look good. We need to style it. So how do you style some data, some UI in SwiftUI? You use what SwiftUI calls modifiers. So it's functions, methods even, that we will call on the views to customize them, configure them a bit more. For instance, you can see that this VStack touches the edges of the screen, and that doesn't look good. You want to have a margin with the border of the screen. And for this, to implement this, there is a modifier called padding. So you saw it a little bit earlier in the default code. And if I call this padding, give it no argument, it will put the default margins around the VStack. What's interesting is that you can see also, I clicked here, and now whenever I go over my code, we can see the space taken by each of my views. And so you can see that the VStack has this padding around it. Okay, then we want to style the text. So the title, we want it to feel like a title. And for this, we're going to use SwiftUI's built-in text styles. And to do this, we use the modifier font that allows us to modify the font used to render the text. And we have some predefined fonts that correspond to the predefined text styles. And so here, the one I'm going to use for my title is called headline. And you can see the style of the title has changed. Now it's a little bit more bold. There is a bit more weight to it. And you can see that I've chosen to implement the modifier in code, but when I implemented it, on the right inspector, this happened. And you can actually change also the font and the modifier by using this inspector. So it kind of looks like what you have when you are using storyboards in UIKit, with one big difference, which is that if I change the font to make it, for instance, a title 2, all it does is actually change the code. This means that the code is the source of truth for everything we do in SwiftUI, which is different than when we are using storyboards in UIKit, because then the storyboard was actually some XML file that stored all the configuration. Here, everything is stored inside the Swift source code, and there is no extra file or hidden file that stores what's been configured here. What you see here is just a reflection of what we have in the code. This can be useful when you, for instance, don't remember the name of a modifier, or you want to try one after the other and go over them, see, okay, how do they look like? Which one should I use? I'm going to go back to using a headline, and then I'm going to want to change the alignment of the, not the text, but rather of the VStack itself, because I would like to have everything aligned to the left, because it will look much better once I've put everything in a list. And for this, I'm gonna go on the VStack, and I have two ways to implement this. Either I use this alignment that you can see right here to say I want to have a leading alignment, and if I do it, once again, just like I said before, there is no hidden file, it just adds some code to your Swift file, and so it added an argument to the init of the VStack saying that the alignment is a leading alignment, and you can see the difference already appearing on the screen. So at this point, you might be wondering, that's funny, but there are some configuration that we do using a modifier, like the font here, and some other that we do through an init. Why that difference? And basically, you will see that difference when a modifier is something that you could provide or not. You can do without. On the other hand, when you have an argument that you pass through an init, it's something that is important. The view needs to have a value to know how to function. So for instance, for a VStack, it needs to have an alignment. Actually, if you don't provide one, there is a default value that is used, which is the default value of the argument in the init. In the case of a VStack, it's center, but the VStack needs to have an alignment in order to work. It cannot operate with an alignment that would be nil. That's why the alignment is an argument of the init, and the customized font is just a modifier, because if you don't provide it, the text can still function. It will just use the system font as a default. Okay. Let's see what is the next step. So VStack, next step is to use a HTag. So I can use a HTag to display the poster image, but before that, I need to build the actual URL to the poster, because here I only have the path, so this thing right here, which is the end of the URL. So actually the beginning of the URL is something static. So I'm going to implement it by doing a copy paste from the finished version. So it looks like this. So we have the URL. So this is just what the developers of the API have chosen as their domain. And here I have this thing that says I want an image that has a width of 400. This way I avoid loading very large images just to display them as little thumbnails in a list. Now I have the poster URL I can use to display the image. And so when you want to load an image from a URL, you actually have a type in SwiftUI called async image that we're going to use actually right now. But first thing we need to ask ourselves is, where do we want to display the image in the view? And me, I want to display it to the left of the title and the overview of the movie, just like it would in an app, like, I don't know, like... does the TV app do that? Like, I would imagine that it does, but I haven't checked recently. But yeah, I can imagine, yeah, I think the Netflix app, it displays the cover and then title and the overview. It just displays with a much more beautiful design than what we have right here, but that's the same idea. So to have this poster displayed to the left of the VStack, we're going to use the H stack. So I'm going to do a command click on my VStack, embed in H stack. And so in this H stack, to the left of the VStack, I'm going to be using an async image, which is SwiftUI's built-in type to load an image from a URL. So it takes as an argument a URL. So that's great because I have the poster URL on my movie. So you can see it's absolutely enormous. That's because I haven't yet given its size to the image. So let's do it right now. So the way I'm going to do it is going to be a little bit different than for other views, because this view has an asynchronous mechanism to it, meaning that the image is not available immediately. So the way it works is that I will need to pass the view a closure to say how I want to style the image when it is available, and the async image view will call that closure once the image has been loaded. So let's pass that closure. So that closure takes as an argument the image. So just to define it, a closure, it's a function that you can pass as an argument and that can be called at a later time. And so you can see the image has disappeared. That's because my closure doesn't return anything. So basically what I'm doing right now is that I'm loading an image, and once it's been loaded, I am ignoring the result. If I return the image straight away, normally, I've made a mistake. I need to implement a second closure for it to work. There's also the placeholder closure that says what we should display while the image is loading. Okay. Now, when I return the image, indeed, the image is appearing just like before, so with no styling. And to have some styling of the image, let's see in which order I do it. First, I'm going to say, okay, what's the maximum width I want the image to have? I want it to have a fixed width, actually, that will be, let's say, 80 points. So for that, I use the modifier frame. So this modifier allows me to specify a size that the image will take. Right now, the image is taking all the space it needs to display, and I'm going to do it. I'm going to say it to tell it, no, you no longer take all the space needed to display the image. Instead, you're going to take 80 pixels to display the image. It still doesn't look really good. That's because I need to tell the image to actually resize itself. The way the frame modifier works, if you look at the documentation in SwiftUI, is that this modifier actually proposes a size to the view. So this modifier proposes to the async image to use the width 80, but the view is actually absolutely allowed to disregard this and take as much space as it wants. So here the image is still saying, no, I have an image, I need to display it with 100% zoom, so I'm doing it. I need to tell the image it's okay to resize yourself, and you do it by calling the modifier resizable on it. Of course, here it's being resized by being squashed horizontally, but not vertically. So I also need to tell it, okay, you can resize, but you need to do it in a way that respects the aspect ratio. And you do that by calling a second modifier called aspect ratio, and you say you want an aspect ratio of fit. Okay, now we have something that looks a little bit more like a thumbnail. The only issue now is that the overview feels way too big when compared to the rest. So let's actually limit the number of lines displayed by this text right here. So we can do it in two ways. Either we use the line limit here or we write it in code. I'm going to write it in code. So the modifier is line limit, and I'm going to give a line limit of 4. You can see that 4 has also appeared in the inspector, because remember, this code right here is the one and only source of truth for the view. And so now this text is limited to 4 lines, and if there is more text than can fit on those 4 lines, we will see some ellipses being added to let the user know that the text has been truncated. Okay, so now we have something that actually almost looks like a usable row for a list. The only difference is, the only thing that's not good yet is this padding modifier, because when I embedded the vstack inside the hstack, what happened was that all the code of the vstack and all the modifiers called on it went into the hstack, including the padding modifier. But this modifier is not where I want it to be, because I don't want to have a padding just around the title and the overview. I want to have it around the entire thing, so around the hstack, and so I'm going to move it and to move it so that the modifier padding is called around the hstack. Okay, I think we are doing pretty good. Let me see. Is it now when we talk about lists? Yes, this is when we talk about lists. Okay, so for now I'm displaying only one movie, but I would like to display actually a bit more movies. I would like to display an array of movies. So I'm going to do that by adding an array of hard-coded movies into my project. And once I will be done with that, we will be ready to make the API call, parse an array of movies from the network, and just swap the hard-coded one for the one I will get from the network. Oh, before I do that, I forgot one thing. The placeholder. What do we display while the image is loading? We have a built-in type in SwiftUI called a progress view. So that one, and it will display a spinner while the view is loading. I see a question, so let me read it. If I want to use a cache to avoid always loading the image from internet, if I have already received it in the past, how should that to assign to async image? That is a great question. I won't cover it because it's a bit beyond the scope of a beginner tutorial, but asking about caching is a great point. I would say you could implement the cache yourself. So either use a dictionary with like keys and value and make it so that your dictionary doesn't hold more than I don't know, like 50 values, so that you don't create a cache that grows but never removes like the older things. You can use NSCache, which is also something that is it's a built-in cache that's available in Foundation, and that has all of this, like removing the least recently used things already built in. And you also have some popular libraries that take care of this caching the image. But you are raising a great point. If your app is all about displaying images, you want to implement some caching so that you don't keep making the same network call to get the same data. Okay, so I was about to implement the hard-coded array of movies, but before that, I see we also have another question. Let me answer it. So, type it, and I will either try to answer it or point you in the right direction when I see it. Okay, so I need to add an array of hard-coded movies. And for this, I'm going to define a new extension. This time, it's an extension on the generic type array, more specifically an extension on the arrays that contain movies. And logic is the same. I have a property mock, and inside I return an array of movie. And so I have my 3 movies, so Jurassic World Dominion, The Outfit, and Jujutsu Kaisen 0. I don't know what that last movie is. Great question. Why do we force unwrap let me display it. Why do we force unwrap the URL? Why is it optional? And it seems like async image accepts a optional URL. Great question. So this is an init for URL that takes a string. The thing is, not all strings are valid URLs. And actually, like you add an extra white space here, this is no longer a valid URL. So this is what's called a failable init, meaning that if the conditions of being able to parse the string into a URL are not met, the init will return nil. I made the choice to do a force unwrap here, probably because I reused that code from a previous live where I needed an actual unwrapped URL, and I was like, okay, this will make things simpler, but you know what? Let's remove it. Let's make it optional. So now the poster URL can be nil. And as you pointed out, async image does accept optional URL, and so it's still working. So actually here you could use both. The only difference is that if the URL is not valid, it won't crash, which is a good thing, but it will probably keep spinning forever, and you might not notice it while you are developing. So here, which one to use is actually it's always a bit of a tough decision. I would say like the force unwrap in a production code might have been a bit too strong, because you, by definition, you don't have control over. I mean, the app don't have control over what the API sends. So it might have been a bit of a risk, because if the API sends a bad path, then the app would crash. So actually, what would have been the best would be either you do return an optional URL like this, which works, or you return a non-optional URL, but instead of force unwrapping, you test if the URL that you obtained by trying to init with this string is nil, then you return the URL of a placeholder image that is stored in the bundle of your app. Thinking about it, this seems like the best compromise, but right now let's keep the optional URL, because it's actually a much better way to do. So thank you, because that was a great question and a great remark. Okay, we're still in the movie file, so I've added the mock array, and this time we're going to use it to display a list of movies instead of just one movie. So first, I'm going to take my property movie, and I'm going to turn it into an array of movies. So I'm going to have to update the preview. So this time I'm no longer calling mock on movie, but rather on the type array of movie. And remember, I can also simply get rid of the type, because Swift can infer it. I need to make the same change at the app level, okay, like that. Okay, hello Wilfried. Next, what do I want to do? Next, I want to adapt the body of the view, because of course the body was expected to work with a movie, and now there is movies, it doesn't know what to do. So how do you display a list of data, whatever that data is in SwiftUI? You use a type called a list. Actually, this is the simplest way to display a list. Then after we will see maybe a few other ones where you have a bit more control, but this is the simplest one. So it's going to take as an argument first the data that I want to display, so movies, and then a closure in which I'm going to build a row of the list. So that closure will take as an argument the element of the list for which to build the row and use it. And as you can imagine, the row will simply be the H tag that I had implemented before. So I'm just going to cut and paste the code inside the closure. And we can see that we have an error. That error is normal. It says initializer, so init with the data and the raw content, which is the closure, requires that movie conform to identifiable. So we are going back to that question of do you need an ID for the struct? The bottom line here is that list in Swift is actually quite smart, meaning that if you update the array with some new data, it's going to compute a diff in order to animate the changes, meaning taking out the cells, the rows. So sometimes I'm going to say cell instead of row because of all the UIKit legacy. SwiftUI uses row to call an element of a list. A lot of people call them cells because how UIKit call them. So don't be alarmed if you see people calling them cells. It's probably they probably mean the same thing. So SwiftUI will compute the diff between the previous array of data and the new one, and then it will animate the list accordingly by animating out of the list the cells or the rows for the data that left the array and making an animated entrance for the data that was added to the array. And if some element in the array change position, then it will animate the change of order in the list. But in order to be able to compute a diff, SwiftUI needs a way to identify a piece of data to say, okay, these two pieces of data are the same or they are not. And for that, it needs an ID. So you have two ways to provide SwiftUI with this ID. The first one is to pass it explicitly as an extra argument. What is the ID? And for that, you use something that's called a key path. So it's a way to refer to a property of a type. Here I'm going to say, okay, in the type movie, the ID is the property ID. If I do that, SwiftUI, the list, now has a way to actually tell which elements are the same and which are not. And so all is good, everything builds and everything displays. But there is another way to implement the same mechanism, and it's to use this identifiable protocol that was mentioned by the error message. The way you do it is that you go back to your type and you make it conform to the protocol identifiable. Identifiable is a protocol with just one requirement, which is to have a property called ID, and that ID must be of a type that is hashable because of the way SwiftUI stores its data. And so here I already have the property ID, the type is int, which is hashable, and so just by doing this, now, just by conforming type movie to identifiable, I no longer need to provide explicitly the key path to the ID. SwiftUI know what the ID is because movie conforms to identifiable. And so we have our list that is working. It's scrolling. There is not enough data yet to be able to have a real scroll where you display new cells as you scroll, but as soon as we implement the actual API call, that data will be here. But for now, everything is ready. Okay, what else did I want to do? I had written in my outline to talk to you about navigation view right now, but I think that's not a good thing. I will talk to it later when we introduce the detail view. So let's get started and let's implement the API call. So before I do, we're going to add a bit more structure here because as I keep adding files, it's going to look like a mess. So let's create a bit of structure. So let's put things in folders. To do that, you do a right click over a file and you say new group from selection. And so, for instance, I'm going to put movie view in a folder called view. I will have all the views there. For movie, I will put in a folder called model, and I will have all my models in that folder, and I'm going to create a third folder, this time not from selection, because I don't want to put my first SwiftUI app file in it. I will call it, service. I hesitated with calling it API, but usually the call that calls an API, it's called service inside an app, so I'm going to keep that naming so that when you move on to other articles, it kind of looks the same. And inside of it, I will implement all the logic to be able to implement the network call. For those who are following along using Xcode, can you share the mock data? Now I'm regretting not having put the link to the project on GitHub. You know what? I'm just gonna try something. I'm gonna try and copy and paste it in the chat. We'll see if it works or if it's going to like... Okay, no, it's way too long. It's way too long. What you can do if you are on the latest version of macOS is like you can do a screenshot of this, and then there is a OCR feature in macOS, or just write some lorem ipsum. But yeah, I should have thought about it. Damn it, for the next live. Okay, let's implement the service. But before that, I see another question. So I think it's also linked to the URL. Sorry if it's a bit late, but could we use an assertion for URL? It would fail in debug mode and wouldn't crash on production. That is a great suggestion. So we could absolutely do it. We could absolutely do it. Oh yeah, Wilfried, you're right. Use ChatGPT. You write the struct to ChatGPT and you ask it to generate the data. It's gonna work. I remember with Copilot, it was able to generate the data, so it's definitely not going to work. And yes, I see a great comment that says that the ID property here is not like the reuse identifier, it's more about definable data source. That is absolutely correct. Reuse identifier was about the UI element, the cell, and that element being recycled with different pieces of data, whereas the ID is about the data itself. So that's a great remark. Thanks for catching it. I had missed that comment. And so you are saying we could absolutely put an assertion. Yes, we could absolutely. Something like this. So let's URL, then assert URL is not nil, and finally return the URL. Let's see. Does it build? Oh, forgot to assign. Exactly. And this way the assertion would crash when you're in debug mode, when the condition here is not satisfied. Not going to go about it in more details, but there is already a video on the channel from like I think it's close to 1 year ago, like last December, I think. So December 2021, about how to use assertion failure, precondition failure. So you can go check it out if you want more details. I will put the code like it was, but that was a great remark. And so now I'm going to implement the service, so where I will make the network call, and you will see that the call will be surprisingly short, but that's because Swift has some great built-in tools to handle networking. So I'm creating a new Swift file. I'm going to call it movies service. And inside of it, I'm going to implement a class. So that class is going to be called movies service. All right. And I need to implement a function, a method inside that type. I will call it get movies, or even get movies from API. This way it is extra clear what's happening here. And so this will return an array of movie. Now let's see how we are going to return that array of movie. So first thing, we need to build the URL to the endpoint of the API we want to query. So the URL for the HTTP request we are going to build. So I'm going to copy and paste it from the finished version of the project, because rewriting the URL is just a way to make a typo and lose time. So it looks like this. So api.themoviedb.org, so version of the API. Then the path to the endpoint, which is movie because we're querying about movie, and then upcoming because I'm interested in upcoming movies. And there is one get argument, which is the API key I'm going to use to make the call in order to be allowed to access the API. So you can get an API key for the MovieDB for free. Just need to create an account and You just need to create an account and request a key. What I'm going to do now is to add my API key to the project. So I already have a file with it. So for that, I'm going to click the little plus and add files to the project. I'm going to look for it. So it's in finished live Swift UI, a file called secret.swift. So it's been added here. So you see nothing. That's because I've added like 100 blank lines before to make sure I don't leak my API key in the video. But now I will be able to use API key right here because it's a constant, a global constant defined at the level of the app. Okay, so here you can see I am doing a force unwrap of the URL. Here I would argue it's okay because all these things here are statically hard-coded inside the app. The URL is hard-coded inside the app, the API key also. So if there is an error here, it's a developer error and basically like the app cannot do anything. Maybe just instead of a force unwrap, I would rather either use assertion failure. No, what I would rather do is have a test that would try to instantiate the URL or call the method getMovies to make sure that actually this doesn't crash, because when you have an app with a lot of screens, it's very easy to introduce a mistake in one of the screens and then not test it because maybe it's a screen that is a bit hard to reach inside the app. But at least for a first version, this seems like perfectly reasonable. So we have the URL to query to get the data. So this URL, this API endpoint is a get API endpoint, meaning we're going to make a get HTTP request to get the data. So it's the most simple kind of HTTP request you can make. So it's going to simplify the code. And so it's time to make the actual network call. And for this, I use URL session, which is, we could say, SwiftUI's built-in HTTP client. I use the shared URL session, which is a singleton that's available and it's already pre-configured with some default behavior like a timeout, that kind of thing. And I call a method on it, call data from URL. So I pass the URL as an argument, and I'm gonna have a few errors. That's because I'm calling this method, which is a bit special, and I need to basically customize my call site to suit all the needs of the method. So let's take a look actually at the error message. So first one is async call in a function that does not support concurrency. Add async to function getMovies from API to make it asynchronous. So indeed, the method that makes a network call is what's called an asynchronous method. I won't go into the details too much. For now, just keep in mind that an async method is a method that is allowed to pause during its execution. Here, for instance, to wait for the data to be received over the network. Since the method can pause, it cannot be called from anywhere, and we need a way to let the compiler know that the method can pause. So since my method getMovies is calling an async method, it needs to be async itself. To say it another way, since my method is calling a method that can pause, the method needs to be able to pause itself. Otherwise, there would be an issue. So to do that, I mark the method as being async. When you call an async method, you need to mark the call site as await. This is just so that when you read the code, it's very obvious to you that right here, there is a call site that can potentially pause the execution of the program. And then there is another error which says call can throw, but is not marked with try, and the error is not handled. So that's the second specificity of the method data from URL, is that it can generate an error, which makes sense because when you make a network call, there are a lot of things that are completely outside of your control. Like for instance, there could be no network available, the server could be down, you could not be authorized to make the request. So you need to deal with the potential error. So there is two ways to deal with an error in Swift, like in many languages. Either you deal with it at the call site, or you just send it up the chain of callers and you let someone else deal with it. Here, we're actually going to let someone else deal with it because we don't really know what to do when an error appears. I mean, if there is an error, best thing we could do here is return an empty array, but is it really the best thing to do? I don't think so. It's better to just let the error propagate up the call up the call chain, and let another part of your code that is better suited deal with the error. In our case, it will be the view to display an error view when there is an error. So to be able to bubble up the error up the call chain, what we do is that we mark our method getMoviesFromAPI as throws, meaning that it can also throw an error. And just like we had to use await to mark that the call site could generate a suspend point in the execution of the program, we mark it with try to also make it clear that this line right here can also generate an error. Okay, now the call site to the method is good. What's missing is that we are not using the return of the method. So let's use it. This method returns a tuple that holds two pieces of data. First, a piece of data, actually, so it's really like binary data. It's the payload, the data payload returned by the network call. And the second one is what's called the response, and it's some metadata around the HTTP response that we received. Here, I'm actually only interested by the data, so I'm going to ignore the response. So we have the binary data. Now all that's left to do is to actually decode it and map it to a struct of type movie. How are we going to do it? We're going to do it by simply marking the struct as implementing the protocol decodable. So this is one of the very magic things of Swift, which is that Swift has a built-in serialization and deserialization mechanism, and simply by saying, okay, my struct movie implements the protocol decodable, the compiler will generate at compile time all the code to be able to decode a JSON with matching fields to that of the properties of the struct. So since my JSON will indeed match the fields, meaning that there will be a field ID, a field title, a field overview, and a field poster path, I will be able to decode the data. And there is nothing else left to be done in my model. That's the only change I had to do, which was to make it conform to decodable. So back to the service. So to decode the data, we need to have a decoder, a JSON decoder to be more precise. So let me create that decoder. So my JSON decoder. I'm actually going to configure it a little bit because, as you can see, in my type movie, I use the camel case. So here in poster path, the first letter of the first word is a lowercase, and then the first letters of all the other words are capital case, like this capital P right here. That's what we call camel case. However, the API uses a different case. It uses snake case, so everything lowercase and using underscores to name the properties. So I need to tell my JSON decoder to convert from snake case to camel case, and for that, on the decoder, I can set a property called the key decoding strategy, and I will say it's convert from snake case. This way, I didn't have to explicitly implement a mapping. You could implement one if needed. That's called the coding keys if you want to take a look, but here I don't need to do it. And thank you, Muhammad. It's great to see that you're enjoying the tutorial. I can tell you, like, I've been working on preparing this tutorial over the holidays, and I was waiting to do it because it's the first video with this format, how to build something from scratch for the first time. I have a video also coming later this month of how to write your first API call, which will be essentially what we are doing. I really like this format. I think it can be very useful to a lot of people. So I'm also very excited about it. And it's great to see that you're enjoying it. So we have the decoder configured. Now let's use it. So on the decoder, I'm going to call a method called decode. This method takes two arguments. The first one is a type that implements decodable, as you can see. So here is going to be movie, and to be able to get the type, I need to do .self. This means I am passing an object that represents the type movie. And finally, for the data, I just pass the data that I had received from the network call. Once again, I have an error as we have seen before, so I'm going to show it, but I think I am over it, but I will read it. Call can throw, but it's not marked with try. just like a network call could fail, decoding can fail because the JSON could not respect the structure of a movie. So I'm going to have to use try right here. And finally, there is one last thing I have forgotten to implement, which is that my JSON will not actually directly contain a movie. It will contain an array of movies. So there is an object that will wrap this array, and I need to implement a struct for it. So I'm going to call it movie response. So this is the top level object in the API response I will receive. I will make it decodable, and it's going to be very easy to implement it because it has only one property, which is called results, and it's an array of movie. And so I'm going to then update here my code to say I want to decode a movie response and not a movie directly. And finally, implement the return value because I said that the function returns an array of movie. And so first I need to store the decoded. So like this, and I'm going to return decoded dot, not decoder, decoded dot results. Why do we have this property results? It's because decoded is of type movie response. And that's it. Our first API call in Swift has been implemented. You can notice that in this file, I'm only importing the package foundation, which is the, we could say, a standard library of iOS. I am not importing SwiftUI, so this code is actually completely independent from SwiftUI. You could use this code in a UIKit app or even in a command line interface app, and it's a good practice to have your data layer, your networking layer, be completely independent from your UI layer, and this is what we've been implementing here. So I wanted to point it out. I see another message in the chat, so I'm going to read it. But if you forget optionals in the URL, the application can crash because sometimes the session API can be more available for the users. It is better at this time to indicate a message in return. Okay, that's a good point, but I think maybe we don't have the same understanding of what is the API key. So the API key is not a session key, meaning it's not something with a lifetime that you need to renew when it expires. The API key is something that you put inside your app, and it's something that grants you access to an API. So an API key, it never expires, and so the only reason why it wouldn't work is if your API key has been revoked, but then arguably your app doesn't work. So indeed, in a real app where such a crash would be unacceptable, you might want to have a mechanism to display an error to say, okay, something bad happened. But here I would still say it's like okay-ish. Whether you use force unwrap or not is always a big debate. Is always a big debate. Here, if you have some tests that actually try to create the URL, I would say it's okay. And actually, no. I was saying something wrong, because the force unwrap is only on the creation of the URL. But then if the network call fails, meaning like if the API key is not valid, the app is not going to crash at all actually, because it will throw an error, and that error will be handled at the higher level. So actually, I am only force unwrapping the fact that this string is a valid URL, and I think it's something that's fine, because this is a static string of the app, and this API key is also a static string of the app. Okay, so how about now we actually use the network call to implement. I forgot what I wanted to say. How about we actually use the network call to load data from the network and display it inside our app? For me in France, it's starting with past 9 p.m. and starting to feel it a little bit, that starting to get a bit tired. Okay. If dynamic, no force unwrap. Yeah, if the UI were dynamic, then force unwrap would be much worse practice. Okay, so we need to be able to call our code from this view. So where could we call our code? We're going to call it by using a modifier that is available on any SwiftUI view called task. So this modifier is very similar to onAppear that you might have seen that calls a closure whenever the view appears. Task is the same thing except that you can call asynchronous code inside of it. So inside this task, we're going to create our service. So I am hard coding the fact that I create the service. In bigger apps, we would want to use something called dependency injection. I won't cover it for this video because at some point it would make the topic feel a bit more too complicated, I would say. But I do have videos about dependency injection on my channel. So if you want to learn more about it, you can go check it out. So let's create the service. So the movies service we've just implemented. And let's call its method getMovies. So this is something that can first pause the execution. So I can use await. And it's also something that can generate an error. So this is where we're going to have to deal with this potential error. For now, I will deal with it in a very simple way, which is that I will define a do catch like this. I will move my code inside the do block. I'm going to say, okay, I'm going to call my method. And if there is an error, for now, I will simply print it to the console and we will display an error view just after. Let me move the preview a bit so that I don't cover it too much. Okay. Then we need to actually store the array of movies somewhere. So of course, we want to store it into our property movies. So like that. It doesn't work. That's because the property is a let and we want to make it a var. So now it's allowed to store this result from the network call inside the property movies. So we are almost there. And let me see. I want to call not movies because we've already called movies inside the method. And let's see. Catch block is unreachable because no errors are thrown in the do block, but there is a try. Let me build. Okay. Okay, it's not happy because property self is immutable. Yes, I didn't think this error would come in at that moment, but it will introduce what I want to show just after, which is that when you want to have a piece of the state of your view to be mutable and to regenerate the view when it mutates in SwiftUI, of course, you need to make it a var instead of a let, but you need to do one more thing, which is to annotate the property with @state. And this is what will allow you to mutate the value inside closures defined in the view, and also let SwiftUI know that whenever the value of the property changes, the body needs to be recomputed and the view on the screen needs to be updated if there are changes between the previous and the new body. This @state is something that's called a property wrapper. It's a feature of Swift. Once again, I won't go into too much detail about it, but if you want to know what property wrappers are in details, I have a few videos on the topic on my channel. So now, actually, let's actually use the app. So here I'm going to give a default value of an empty array when the network call has not been made yet. This way I can get rid of the mocked movies. Let's resume the preview. It should make the network call and we should get some data from over the network. So you can see that now we get some more recent movies. Let me move the preview a bit. So we get some more recent movies because my mock data, I had gotten it like back in July when I was making my first videos about the MovieDB. That's why the movies were movies from last summer, like Jurassic World Dominion. But now we have more recent movies like Puss in Boots 2, for instance. And you can see that when we scroll, we have all the data displayed. So the first page of result returned by the API. So we've already implemented in just a bit more than 1 hour a first SwiftUI app that fetches data from the network and displays it in a scrollable list, which is already a nice achievement, I would say. But we are not going to stop there because I still want to show you a few more things to go a bit further. What I want to do is to show you how to introduce a bit of architecture inside the view we've made. So to create something that's called a view model in order to separate a bit more the pure UI layout logic from the rest of the logic. And then we will implement the detail view in order to start dealing with navigation in a SwiftUI app. So let's begin by introducing a view model. So this view model will be useful to allow me to represent different states of the view, like a loading state while the network call is being made, an error state if there is an error, and a loaded state when data is available. So how can I do this? Let's start by creating the view model. So I'm going to create a new group. I'm going to call it view model. I'm going to put it at the top of the hierarchy. So for now, I am storing things like service model, view model. In a real app, you wouldn't want to put all the view models together, all the models together, and all the views together because it's not a logical way to do it. You would want to do it by feature. And so for each feature, have its views, its view model, its service, do it that way. So here in the view model, I'm going to implement a new Swift file. I will call it movies view model. So by the way, my movie view, I'm going to rename it to movies view for the sake of consistencies. And I see a great question. In case we wanted to change the method to post instead of get, what do we do to make this change? Great question. I will just show what you would need to do. I won't cover everything, but basically, here I call the method data from URL, but there is another method you can call, which is data from data for URL request. And the URL request is basically a URL along with more configuration like the HTTP method, so get, post, put, delete, a body. When you're doing a post, you have a body, the query string argument that you can also represent. So you would create a URL request in between your URL and the network call and use that URL request. That's how you would do it. Great question, by the way. So let's go back to the view model. So I'm going to implement this type that will hold the logic that the view will be using. So the responsibility of the view model will be to load the movies and to let the view know, okay, are we loading right now? Has there been an error or is the data ready? So let's implement a class called movies view model. And I'm gonna have to write a bit of boilerplate code in order to make this work and to let SwiftUI know that this is a view model that holds logic that will have an impact on how the view is drawn. So first thing I'm gonna do is that I'm going to make it conform to a protocol called observable object. It's basically a protocol that will allow SwiftUI to know that something has changed in the state of the view model, and so the view needs to be redrawn. Then I'm going to annotate my view model with @main_actor. And this will let the Swift compiler know that whenever I am writing code that uses async await, whenever in that code I am updating a property of my movie view model, this needs to happen on the main thread. This is a very important thing because in SwiftUI, just like in UIKit, you are only allowed to update the view from the main thread to basically prevent all kind of data races bug. And this is how you do it with code that uses Swift concurrency. So code that uses async await, you annotate the class with @main_actor. Once again, I'm not going too much into detail, but if you want more details of what main_actor is, I have videos on my channel about it. And finally, we're going to start implementing the rest of the view model. So for instance, the view model will be responsible for making the network call. So it will need to own an instance of our movies service. I'm creating it inside the view model and storing it as a let, because once the service has been created, we will never change it. I see a question, I'm going to read it. So Wilfried is saying, I always struggle to pick between the two possibilities, or view models together, together, layer per layer, or functionalities all together. Yeah, I used to hesitate a lot. Now I would say I would almost always go with grouping by features, because you're much more likely when you're looking at the view for feature A to look at the view model for feature A just after, rather than look at the view for feature B when you're looking at the view for feature A. You know, like there is a name for it, like locality. You know, like you when you reason about your code, you more often have feature locality, we could say, rather than kind of object locality. So that's my logic and my argument for grouping it that way. So we have the service. We're also going to need a method to load the movies. So that method won't return anything because the movies will be stored in a property of the view model. I will still need to mark it async though, because that code will call an async method. And basically, I will be moving code from my view. So this code right here, I'm going to move it into this thing right here. Of course, I don't yet have an array of movies, so I'm going to implement one actually. So I'm gonna say my view model can store an array of movies. So right now I'm doing things just like I was in the view. I'm basically moving code from the view to the view model. And remember, in the view, when I wanted to let SwiftUI know that when a property had changed, the view needed to be recomputed, I used addState. Here, it's kind of the same logic, except that since I'm not in a view, I'm in an observable object, I use a different property wrapper called addPublished. But the idea is the same. When you set a new value to a property marked with @published, it will let SwiftUI know that whatever view is listening, is using this view model, need to have its body recomputed and have the new body compared with the previous one in order to know whether or not the UI needs to be updated. Okay, so we can store the array of movies. Of course, we need to deal with the error. So what I'm gonna do is, just like before, if there is an error, just catch it and print it to the console. Maybe print its localized description. I will improve this a little bit later. But for now, I have moved all the logic that was in the view to deal with loading movies into the view model. All I have to do is to actually use the view model in the view. So first, let's start by cleaning up some things. So this code can go. Here, this code can go also. So I need to have access to my view model inside my view now. So I'm going to create the view model. So like this. So this is not enough because I still need to let SwiftUI know that when the view model changes, the view needs to be redrawn. So basically, I need to tell SwiftUI that movies view listens to changes in this view model. And I do it once again by using another property wrapper. This one is called addState_object. It's basically the same thing than addState, except that addState object applies only to properties holding a observable object. And remember, observable object is the protocol that we made our view model conform to. Okay, now inside the list, of course, we cannot access directly movies. We need to access viewModel.movies because the movies have been moved to the view model. And finally, we need to call the method loadMovies from the view model. We call it inside task. So await viewModel.loadMovies. Let's see if it works before I keep on my explanation. So it's failing to build. Let's see where is the compilation error. So where is it failing? Okay, because this argument no longer exists. So I can remove it. Perfect. So normally we should have the same behavior than before, data being loaded from the network. Perfect, it's still working. At that point, you might be wondering, but why is he calling the method load moveView? That's not a correct name, so let's use a rename for it. Now you understand why I didn't even trying to copy and type the path and the endpoint URL, because I would have made these mistakes all over the place. I see a great question in the chat, and I will answer it just after. So you might be wondering, why is he using the modifier task to call the method load movies? Because the view is responsible for initializing the view model with this code. Why am I not calling this inside an init of movies view model? And the reason is that actually the struct movies view could be created way before the view is actually displayed. And so if I were to implement the call to load movies inside the init of the view model, the network call would be fired basically as soon as the app is created, even though the view might never be displayed. So right now it wouldn't be that much of an issue because there is only one view in the app. So whether you call it in the init or in task, it's basically at the same moment. But when we will introduce the detail views later, there will be one potential detail view for each row in the list. If we were to load the data in the init, we would basically load all the data for all the detail views at once, even though we will probably never use it. And so we would just be wasting network and CPU resources. So it's really important to never do anything that's costly in the init, whether it's the init of a view or of a view model or of an observable object, because these inits will be called very early on, way before the view is displayed. The view might actually never be displayed even though the inits have been called. So this init must be as lightweight as possible, and all code that actually is costly, like making a network call, should happen in like a task modifier and on appear modifier, something that is called only when the view is displayed. There was a great question in the chat. Why not the observed object modifier instead of state object? So there are two modifiers, that's true. There is also another one called observed object, but they do have a difference, which is that when you use observed object, the view doesn't have ownership of the view model, meaning that there can be cases where the view would be redrawn and a new view model would be created, and so all the data loaded from the network would be lost. On the other hand, I was looking for which liaison word to use. On the other hand, when you use state object, it's the other way around. You are saying that movies view owns the view model, and so even if movie view is recreated, the state object will not be recreated. We will keep having the same instance. Historically, it's interesting to know that when SwiftUI was first introduced in iOS 13, as state object didn't exist, which could lead to some subtle bugs, and so that's why in iOS 14 they introduced at state object. But that was a very good remark. And Matthias is saying, the preview is now dependent on the view model data to show information. Do developers usually create a constant mock for this? How is it dealt with? Great question. Here I can tell you like what we do at work in our case is that we create a mock view model. So basically we would have a mocked version of the view model. So for this we would use dependency injection in order to be able to inject the view model through the init of the view, have the view model be abstracted behind the protocol. So once again, I have lots of videos on dependency injection that explain this in detail. And once you have this, you would implement a mocked version of the view model where basically you would have an array with some hard-coded data, and load movies would do nothing, for instance. And you would use in the preview this hard-coded data. That's what I've been using at work for the past month. And yeah, we're quite happy with it with my colleagues because we feel like it's the pragmatic choice, meaning that it gives flexibility without having too much overhead in your code. And so that's the solution we are having right now. Okay, so the code is working. That's perfect. Let's see. You would love to see these mocked protocols. You know what? I'm going to make a screenshot for me of the question Mateus asked, because I am in the process of making small videos at work about what we do when we work on Photoroom. Actually, some videos have been recorded. The editing is in process, so this is going to come in the following weeks. But this is a great idea for potential topics, so I have made a screenshot. Maybe it will be covered in a future video. Okay, and a question that says, "Hi Vincent, I want to learn SwiftUI, but do you think I need to learn Combine first to understand more how SwiftUI work? I had bit experience with UIKit before." So Combine is the framework that SwiftUI uses under the hood to deal with all the observing thing. Combine is becoming less and less a must known to get started with SwiftUI, at least because SwiftUI now can use async await for all the simple use cases. And actually, in this entire tutorial, I don't think we're going to use Combine once. I don't remember writing Combine code when I, you know what? I'm going to take my finished project. I'm going to search for Combine. No, we won't be using Combine. So you can build a SwiftUI app without using Combine. So I would say you can start learning SwiftUI without focusing too much on Combine. And when you reach the point where actually you need to use Combine, then you can focus on it. But you don't need to learn the two in parallel to get started, which is kind of cool because it basically like makes it a bit easier, because Combine is quite a strong topic, and so being able to focus only on SwiftUI is kind of nice. You know, like let's do things one step at a time. Last thing I want to say is that the full support of async await in SwiftUI came with iOS 15. So if you're using iOS 14 and before, if you have to support it, you will not be able to use all of the nice little things like the task modifier. You can find version implemented by the community, but not the one offered by Apple. Okay, I'm looking at the paper with everything. So observable object done, add published done, async method done, state enum. We want to have a state for our view. So our view already has some state, which is the array of movie, but we want to have an explicit state to say whether the data is loading, whether there's been an error, or whether it has loaded and data is available. And this is where our view model will shine, because for now I have just moved some code away from the view to the view model. Now we are going to add additional logic to the view model, up to the point where you're going to feel like, okay, if we had implemented this in the view would have been a mess. So it's a nice thing that we have moved it away from the view into a dedicated object that I have called movies view model. So let's implement my states. So I'm going to use an enum. An enum, very simple way to explain an enum. It's a way to define several possible states that are mutually exclusive, meaning you can have either one but not two at the same time. So my enum, I will call it state. You can see I'm declaring it inside movies view model. So the full name is movies view model.state. And so there will be three cases in this enum: loading, for when the data is loading and we want to display a nice little loader. Then loaded, from when the data has been loaded and data is available. And the nice thing is that a case of an enum can actually hold data, just like a struct can hold properties. So I will have my movies in that case when I am in the state loaded. And finally, a case error. And in that case, I will have the error that occurred. Then I'm going to change my published property. It will no longer be the array of movie. Instead, it will be a state, which will be of type state, and the default value will be loading. And what's gonna happen is that my method load movies will no longer on its result, will no longer assign its result to the property movie. Instead, it will assign it to the property state. But you cannot directly assign an array of movie to the state. You need to use this loaded case. And so I will say, okay, when the data has been loaded successfully, I want to update my state with the case loaded. And what is the array of movie? It's the result of the network call. Here I've written it as a one-liner. It's not a great way to write Swift code because there is a lot of things happening on the same line. So actually, I'm going to cut this code put it in a variable. So let's movies like this and like this. Don't hesitate to like really like split. How do you say découper in English? To split your code in little pieces like this, because it's not going to degrade the performances of your code at all. The compiler is smart enough to just take this code and put it here. But when you're reading the code, it makes the code much more easier because you've splitted things and you've given an explicit name to your intermediary results. So that's how I deal with the success case. And now for the error case, I can update the state property with the case error and saying, okay, well, this is the error that happened. Now the view has to deal with it. So we've changed the implementation of the view model. Now it's time to change also the implementation of the view to reflect these changes. It's breakup. Yes, I was thinking split because split is the name of the tool in Final Cut Pro. When you edit videos, you have some nice little scissors, and it's called split to be able to split a clip into two. So that's why I thought of this one. Okay, so how do I update my view? So here we're going to use a great technique in SwiftUI, which is that in the body of a view, we can switch over an enum. And so I can switch over the state of my view model, and I can write a case statement for each possible case. So I had hoped that the Xcode compiler would generate it for me, but it's not a real Xcode Live if Xcode doesn't bug at least once. So it has, and I will just write them myself. So here I have several states to deal with. The first state is loading. And what view do I want to display when it's loading? I want to display a progress view, so a spinning loader, actually the one you're seeing right here. Then when I'm in the case where there is an error, I want to, for simplicity, what am I gonna do? I can start by showing a text that will display the error with the localized description like that. I'm going to start with this, then I will, because I want to move the code that's behind, and that's basically making everything not compile. And the last case I want to deal with is the case loaded. Oh yes, that's because you put semicolons after a case, not an opening curly braces. Okay, and the case loaded, where I have my array of movies, so like that. And this is where I'm going to move my list. So I'm going to move it here. Then we will refactor a little bit. Okay, and finally there is the question of where do we call the task modifier? Where do we call it? So there is a little trick to it, is that we can put our switch inside what's called a group. And the group, it's a container, so just like a VStack or an HTag, except that this container doesn't have any impact on the layout. It's a purely logical container. And what's nice is that on this group, you can still call a modifier like the modifier task. Okay. Now the code should build. Let's see. Do I have everything? So now my movies are no longer, I no longer get them from the view model. I mean, they still come from the view model, but the view accesses them from the case in the enum. Okay, it seems to be doing something actually. At least it's building. Where am I calling the modifier task? I'm calling it on the group. All right. So it seems like we are never switching to the case loaded. I'm trying to understand why. Let me see. Did I make a mistake somewhere? So here I update with state loaded. Error, all right. Let me put I'm gonna put a breakpoint to see like if the task is indeed called or not. Maybe when I used the group, I was a bit too ambitious, and actually it's not making the network call. Let's see. Okay, so yes, the network call is happening. Okay. Okay, so actually it's only in the preview. Maybe the preview just hadn't refreshed. Let's see. But at least if I use the simulator, you can see that in the simulator, it's working. So for some reason, the preview doesn't want to work right now. It can happen sometimes in SwiftUI that in SwiftUI in Xcode the preview becomes a little bit annoying. We will see if it starts working better. We'll be using the simulator for now. If you see, it's because the preview needs the async call. So the preview, I'm showing the movies view, and normally there is no difference between what's happening in the app and what's happening in the preview. So you know what? What I could also do is simply move this here. Let's see if it has an impact on the preview or not. Because here, if I call it on the loader, if I call a task on the loader, there is no reason for it not to work. Yeah, it feels like the preview is a bit lost. I'm going to use the simulator to finish. Okay, last thing is dealing with is refactoring things a bit, because this switch statement is starting to become a bit bloated, especially the list right here. So we can refactor code outside of a body, because a body, even though it looks a little bit special, it's actually just a computed property. So we can extract our code to build the list inside a method. So let's try and write the signature of this method. So like that. So the method, I will call it list of movies. So the method will take as an argument the array of movie, and it will return some view. So this sum is what's called an opaque return type. Not going to go into too much detail about it, but basically it's a way to tell the compiler the return result will be something that conforms to the protocol view. And so inside my method, I'm going to move basically all the code that was creating the list. So all this code goes right here. And in the body, in the case loaded, what I do is that I simply call the method list of movies. And this should be working without any issue, because we can actually split things into method. Someone is saying the audio is cutting out. I don't see any error on my streaming software. I hope it's going to work. It's not going to last for too long. Sometimes the simulator can make the audio go a bit crazy on macOS. Ah, damn it! I hope it's not that. I will kill the simulator. Audio is good for you. Okay, so maybe it was. I was scared. Okay, let's go back to the code. Okay, good. If it's good for most people, that's great. Audio is cutting out for some people also. Okay, I'm going to keep on and we'll see like how it goes. So I have split things. We have the state enum. Oh, I see something interesting. Function should be marked private. Yes, we could mark it as private indeed. And maybe view builder, that's a great question. So first thing, should we mark this function as private? We could, even though, to be honest, the way you use a view in SwiftUI is that you will embed it into another view, and you will simply call the init. So it's very rare that you store a view in a variable and then call methods on it. So you could mark it as private, but most of the time you won't be able to anyway call the method. But indeed, it could be a good practice. I must say that at work we try to split things a lot into SwiftUI packages, and so internal is kind of like private for the rest of the app. That's also why, as a default, I don't always make the methods private. This view model could also be private. I think it makes even more sense because here it's part of the state really of the view, but that's a very good remark. And the other is, should we or shouldn't we annotate the method with @viewBuilder? That is a great question. I won't go into the details of what Add View Builder is because it's way too complex, but basically, let me just give you the gist of it. As you can see, at no point in here there is a return statement. In my H stack, I pass it several views. Same thing for my V stack, but I'm not passing an array. So there is no magic in computer science. Something has to do the job of telling the V stack, okay, these two things, these two texts must be collected into an array. This is what View Builder does. You can see View Builder, which is actually a result builder, as the name of the feature in Swift, as like a very tiny compiler that helps you take this syntax right here into another syntax, which is using an array, basically. And so here we don't need to use View Builder because we are just returning a list. So we're returning just one thing. However, if I had a code that was a little bit different, like if I was, for instance, doing an if statement, like, I don't know, like, let's do it. Let's try it. I do if movies is empty equal false. So if there are elements inside the list, I return I return the list. Let me fix this. Else, I just return a text that says no movies, no upcoming movies. That's actually something that's reasonable. Like in most apps, you want to have what's called an empty state for a list. You can see that. Of course, I need to add the return statements because before I didn't have to write them, because when a method has only one line, that line is assumed to be the return value by Swift. And so I have an error. Function declares an opaque return type SomeView, but the return statements in its body do not have matching underlying types. And the reason is that SomeView, for the compiler, it means this method will return some possible view. Some type that returns that some type. I'm gonna redo it. SomeView means for the compiler that the method will return a type that conforms to the protocol view. But it means that every call to the method will return the same type that conforms to the protocol view. Another way to say it is that the actual return type of the method is known to the compiler at compile time. This is an issue, so we could use group, for instance, and this is actually kind of what View Builder is doing. What we can do, short of using group, is to use @View Builder, and here, when I do that, it's still not happy. Maybe because I need to remove the return statements in that case. Yes, in that case, it works. And so now it works. Why? Because @View Builder is doing this kind of transformation of the result, and it's not putting them into a group, it's putting them into what's called an underscore conditional content, if I remember it correctly. I don't know if it's conditional content or conditional view, but basically it's taking my if statement and it's translating it into a view that will have two possible renders depending on whether the condition is true or false. So like I said before, View Builder, here it turns two elements into an array. View Builder can also turn an if statement into a data type. So it takes instructions and turns them into data. That's why I was saying it's kind of like a small little compiler in the language. And so that's a potential way of using @View Builder. Actually, I will leave it in the code because it makes sense to have an empty state for the view. So that was definitely a great remark. And I have a few videos on the channel about result builder and how to use them to implement what's called DSL, so domain-specific languages. If you're interested in the topic, you might want to check them out because result builder are quite powerful in Swift. Okay, we have almost everything. All that's left to do is to implement the detail view in order to deal with some navigation. So I'm gonna go a little bit faster because I don't want the live to last for too long, and anyway we'll still be doing the same things than we've been doing before. So for instance, we're going to start by implementing a new API call to get the cast of a movie. So I'm going to implement a new service called cast service, and I'm going to also implement a new piece of data model because I will call how did I call it? I called it movie cast member. So I'm going to use the same name. This way I can copy and paste to win some time. So what's a movie cast member? So it's the data returned by the API. Just going to copy and paste so that we don't lose time. So there is an ID, there is a name of the actor, and character, name of the character played by the actor in the movie. It's identifiable, equatable, and decodable. I added equatable at some point. I'm not sure why. I will remove it. This way, if there is an error, it will give me the occasion to explain why. Then I also have some mocked data. So it's the cast of Jurassic World Dominion, as you can recognize if you've seen the movie. So we have our data model. Just like before, the data will be in an array returned in a top-level JSON object. So I will have a movie cast, a movie credits response, and it will contain the cast. So I have implemented my data model. Now I can move on to implementing the cast service. I will also copy and paste because it's the same behavior than before. I have a method getCast. The only difference now is that this method takes an argument, because for getMovies, there was no argument. We wanted to get the list of movies, so we could say the entry point of the data model of our app. Now we want to get the details of a movie. So this movie is passed as an argument, and we use the ID of the movie in the building of the URL to the API endpoint, which this time is /movie /the movie ID /credits, and still the API key, and then make the network call still using URL session shared data, because it's still a get HTTP call. We decode just like before. You can see this time I'm storing the JSON decoder inside the class. I could also store it as a global constant of my project. And finally, I return the array of movie cast member. So for the service, nothing new. For the view, let's implement the view. So it's the first time actually in this entire line that we are creating a SwiftUI view, because up until now I was using the view that was created when I had created the project. So when you create a SwiftUI view, you can use SwiftFile if you want, because it's a SwiftUI view is a Swift file, but there is one that's even better to use, is SwiftUI view, because you will see. So I will create my view. I will call it movie details view. It creates a struct with a preview and everything working. How do you usually use URL components for URL creation? I'm not going to cover it. Honestly, I would say search on Google, and if you see an article from either Hacking with Swift or John Sandel's blog or Donny Val's blog, you can trust their content. I'm sure that one of the three, or Antoine van der Lee's blog, one of the four, they have an article on the best practices, but it's a great topic. I'm also going to make a screenshot of it because, for a future video, best practice of using URL components is indeed a great topic. Okay, let's implement the movie details view. So this view will be a view that will be pushed by the navigation when we select an element in the list of movies. So this view will need to have two pieces of data. I'm not going to create a view model for this one to keep things a little bit simpler, but we could, and it would be the same logic. So first there will be a let constant, which will be the movie. Why am I declaring the movie as a let constant and not an @state var? Is because the movie will be passed in the init of movie details view, and it will never change, because when you have selected a movie in the list, you want to see the detail view for that movie, and you need to go back to the list and select another movie to get another detail view. That's why the movie is a let constant. On the other hand, the cast of the movie that will be retrieved through a network call, that one will be an @state var, because it will be updated when the network call returns. So this is an array of movie cast member like that. Okay, we need to pass it as an argument. So for the movie, we have our mock movie. for our cast, we have our mocked cast. So that's when you see when this extension with the mocked variable takes all its usefulness, because you can then write the call sites very quickly. Let me remove this extra space. And now I can actually start implementing my view. So let's actually do it. So how are we going to do it? Well, what will we begin with? Let's begin by actually the list. So I'm going to implement a list. It will be a list of cast members. I made movie cast member conform to identifiable, so we are good on that end. Okay. So the closure where I build the row of the list. And so I'm gonna have a vstack inside that list. First, I will have the name of the character. So you can see the name of all the characters from Jurassic World Dominion appearing. And then below, the name of the cast member, so the name of the actor. Okay, and in order to be able to differentiate them, I will make the name of the actor be of text style caption. This way, it's written a little bit smaller. Okay, we can see that the data written by the API is not super well formatted, because sometimes there are some extra spaces. So like if you want an exercise to keep on after the live, you can try to implement a view model in which you add the fact that you will trim all the extra white spaces at the beginning of the lines. Let me see. Oh wait, that's weird, because there are no actually. No, I get it. Wait, that's weird, because yeah, I'm using this data and there are no white spaces. And here, oh, maybe that's because, oh, I get it. Okay, I get it. Before I give you the answer, can you guess why it looks like there are some extra white spaces for some of the name of the characters? And a hint, there seems to be more white spaces for longer character names. So do you see the reason? We actually covered it a bit earlier in this live. And yes, Matthias, the live will be saved. As soon as it's finished, it becomes available with a replay straight away. So text is not aligned to the left. Yes, exactly. By default, a vstack is aligned to the center. And that's what's happening here, actually. The list displays from its leading edge, so to the left in that case, because I'm using a language that reads left to right. However, since it's centered, when the name of the actor is longer than the name of the character, then the name of the character is centered with respect to it, and same thing. So you've written the code in the comments with read. So I will say alignment. So not left, but leading, because this way, when you have a right to left language like Arabic or Hebrew, it will be switched automatically. And now it all looks nice. Perfect. And funnily enough, I had forgotten to write this in the finished version of the project. So I will be updating it before I put the link of the GitHub in the description. Okay. What's the next step? Next step is to actually, I mean, we have like this cast member, but you still want to display some context about what movie it is. So you want to display basically, again, the poster and the title of the movies, etc. So I'm going to copy paste the code, but it's going to be an H tag like that. But the question is, where do I put this H tag? I would like to have it in a header of the list. And right now, that's not the case. I have the H tag, and then the list, I would need to group them somehow. So I could try a vstack, but it won't be that great. It's going to look... yeah, it doesn't look good at all, and plus only the bottom like scrolls, it's a total mess. Fortunately, we can improve this very easily, because we can kind of like split the list into two parts, because in the list, when you think about it, there are two different things. There is the presentation logic of it, which is the fact that you see the list, it has like the rounded corners, the padding, the separator. And there is also the fact that the list iterates over some array of data. And it turns out you can very easily split these two things. And for this, you turn the list into a for each. So for each is a view that is going to iterate over some data, but it will not add any layout logic. So just like group wouldn't add any layout logic, for each is the same thing. It's a group with iteration built in. And then that for each, you can embed it in the list. And the list will take care of adding the layout, the UI logic. So you can see we are back at the results we had before, except that we have split the UI layout part in list and the iteration of the data part in the for each. And now that we have this, we can actually put some things above the for each. We can create another section in the list. This one will be a static section. As you've probably guessed, I'm going to put my HTAG inside of it. And now I have it's not the most beautiful design ever, mostly because, yeah, like that's not the most beautiful design ever, but it works, meaning that it scrolls entirely. The header is in a real header of the list that scrolls, etc. So that's one of the nice features of list, is that you can split it in order to have on the one hand the layout logic, and on the other hand iterating in the data. Like like you say when you're a developer, like I'm no designer, this is the best I can do. We're still going to improve a bit on this because we're going to add the navigation part to it. So we need to implement now the navigation and the data flow. So basically we need to embed the details view in the movies view, the list view. Before this, I'm just going to add the code to make the network call. This way, my view is going to actually work when I use it in the real app. So for this, on the list, I'm going to put a task modifier that will simply use the cast service to make the network call and assign the result. So like this, I'm just ignoring the error to go a little bit faster. We could implement a view model, and we should implement a view model just like in the list of movies case, and you can do it afterward if you want to give it a try. Okay, and in the preview, I can still use the mock version. So now I need to make the data flow between the list and the detail view. And for this, I'm going to use the simplest way in SwiftUI to implement a navigation, which is to use navigation view and navigation link. So how do we do it? Here, actually, yes, it's true that this one is still loading, and that's super annoying. You know what? So short of implementing a fully mocked view model, what I'm gonna do is here, so in my movies view model, instead of having loading as the default state, I'm going to have loaded with my mock array. Of course, don't do this. Because it's not production ready, of course, but it will just like make the preview work again so that I can finish the live in good conditions. Oh, would you believe it? Like as soon as I do this, now I've got the actual good network call data in the preview. Wait, that's super weird because the view model. That's super weird. Like, why is it working now? So now it's not working in the preview, but I'm calling load movies. And what's super weird is that when I put, so as a default value, my mocked values, then the preview actually works and actually makes the network call, because this is not the data from the mock, this is data from the network. This is incredibly weird, and I don't have an explanation for why there is this error actually, because Yeah, I don't. If you have an idea like why there was this bug, I'm all ears. At least we can use the preview again, but this is super weird. But let's go back to it. So navigation view, I don't think it's deprecated. You have a bunch of navigation links that have been deprecated, and then you have navigation stack, which is a more complex way to deal with navigation. But I'm going to use the more simpler one because this is supposed to be a beginner tutorial. So how do you use navigation view? First thing is I need to embed my view inside the navigation view to be able to push a detailed view onto the navigation stack. So I will need to do it in two places. In my actual app, I will need to embed my movies view in a navigation view. So actually, yeah, this one has been deprecated. You're correct. So now you're supposed to use navigation stack actually. You know what? I'm going to try and use this one and we'll see if I run into a bug. This is the part where I'm improvising. So I'm putting both my app in a navigation stack and also my preview because the preview doesn't inherit anything from what's defined in the app. So I also need to embed it inside a navigation stack because otherwise it just won't work inside the preview. My navigation won't work inside the preview. Actually, now that in the preview, my view is in navigation stack, I can start implementing a navigation title. So here I can add the modifier navigation title and display as a title, for instance, upcoming movies. And you can see the title is starting to appear. I could make it even a large title. So for this, I think there is something called navigation title, navigation title style, like something around that. I don't remember. Navigation. You know what? Actually, now I remember why I wanted to use navigation view and not navigation stack. I got carried away wanting to improvise, but the reason is that navigation stack is only iOS 16. And so if you're working on an app today, there is a good chance that you still need to support at least iOS 15. And so you can't use navigation stack yet. That's why I wanted to use navigation view, which is the component that most apps today have access to. And like at work, we're still supporting iOS 15, so we're still using it. That's why I wanted to use it. And so it's been deprecated, like you said, which means that it will be removed in a future version of iOS. But if you have to support iOS 15, you still need to use navigation view. That was the reason. So I'm going to put it back. You can see a little bit difference in behavior because navigation view by default has a large title, whereas navigation stack doesn't. So we have this extra thing in the UI, and now we will be able to implement a navigation link. So a way to link an action, a click on a row of the list to a navigation to the detail view. So to do it, we are going to wrap the row of our list in a navigation link. So to understand what I mean by that, I'm going to implement navigation link. I'm looking, yes, I want this one. So I need to pass it two things, a value. That value is actually, no, not what I wanted to do. That's when you want to use the more modern thing. I want the navigation link, destination, and label, the one that most apps are still stuck with until at least next year. So there are two arguments to navigation link, two closures. The first one is the destination closure. So what should the navigation link lead to? And the label, what should the navigation link display? The label is easy to implement. As I said, it's the row of the cell. So I'm just moving the code around. And the destination, it's the movie details view. So I'm just going to instantiate it. Now you understand why I was saying that the init can be called way before the view is displayed and can even be called when the view will never be displayed because the user will never tap on that specific row. And so the argument to movie details view needs a movie as an argument. That's a good thing. We are building a row, so we have access to the movie. So we just pass it along. you can see that a little disclosure indicator has been added by the list automatically, because the list is able to recognize that there is a navigation link inside and adapt its UI consequently, in consequence. You can also notice one of the big downside of navigation link, which is why navigation stack was introduced, which is that we need to know the destination where we define the link. This means that we need to be able to access movie details view from movies view. When you work in a big app, this is a problem. That's why you have a navigation stack that has been created. And with navigation stack, you actually say, okay, I want to navigate to that object, which would be the movie. And then some other part of the code would say, okay, when you're told you navigate to a movie, you display a movie details view. So you're able to split basically the two things into two parts. Here, that's not the case, but since we're on a simple app, that's not too much of a problem. And now, normally, if I click on a movie, you can see that the navigation to the list, to the details view, actually works as expected. So pretty great. We've implemented the navigation. I'm going to update the movie details view a bit. So if I click on the file, I will switch to the other preview. That's not what I want. So this is where this little pin icon comes into play. I can select it. And now the preview is pinned, meaning that if I switch to another view, I will have my new preview, but I can go back to the pinned preview also. So for instance, I would like to have the navigation title here to be the title of the movie so that there is an idea of the user know where he is in the app. So for that, I'm going to implement the modifier navigation title. This time it won't be an hard-coded string like upcoming movies, but instead it will be the title of the movie. So you can see when I click, it's displayed here. Not the best way to display it because it's actually quite big. Let's see. I don't know if there is an easy way to improve it or if no, I think it's okay to leave it like that because it's not the big focus of what I want to show you. Actually, do I still want to show you some things because I'm looking and it seems like we've done everything I wanted to do. So we are just a little bit above 2 hours. So perfectly on time from what I had planned. Yeah, what could we do? Oh, yes. Let's do one last thing that I wanted to do and I haven't implemented. In the error case, a little bit earlier, I said we could improve it a little bit more. How could we improve the error case? For instance, by displaying a retry button. How do you do it? You simply take the text that simply displayed the error, you put it in a VStack. Below, you put a button. I wanted to show you an example of using a button. So a button, it has several in it, but the simple one is to have just title and action. So the title is a string. I'm going to write retry. And the action is simply to again call the method load movies on the view model. Since the method is async, I need to call it inside a task. And so now I have a retry button to be able to retry when the network call has initially failed. I have quit Xcode because I did command Q and I didn't want to. Ah, damn it. Let me open it back again. It's the end of the live and everything is crashing into flames. Okay, Xcode is back. Perfect. Xcode is back. Let me just put it so that you can see it again. All right, we are back. Okay, let me display where I was before I crashed everything. So I had just implemented this thing. Okay, and yes, you're right, Wilfried. What I want to have is here. So if I go like this, so to show and hide the preview, it's Command Alt and Enter. Going to display the preview again, and you were suggesting to have the style to be inline for the detail view, which is a very good suggestion. So let's do it. And so the modifier you are seeing, it's navigation bar title display mode inline. Indeed, like that. Okay. actually, I have opened the wrong project. This is the finished version of the project. So in the finished version, you will have also, I had implemented this little thing. Okay. Okay, I see we have some people spamming the chat. So I'm just going to ban them. Perfect. Okay, let me check all the messages. You need to customize. Okay. So that's what we've just done it. You can use, yeah, if you want to customize the navigation title, actually, in SwiftUI, you don't have a lot of choices. To tell you, like in a more complex settings, what we've been doing at my work is to create the individual views in SwiftUI, but to still manage navigation in UIKit because you have more control over it. And when you want to have very fine controls for analytics, for a lot of possible things, it was easier for us to do it like that. Also because we can't use navigation stack yet, and so navigation was easier to manage like that. Okay, so last thing I've implemented in this project, so it's the finished version that you will have on GitHub. I had implemented a share sheet. The preview crashed. Let's retry it. Yes, there was a share sheet that I had implemented to show you how to show a modal view, because we've done navigation by pushing, but not by presenting modally. And so the way it's done in that case is to actually, let me find the code. Where did I put this? So it's here. The modifier toolbar allows me to add something in the navigation bar of the navigation view, and I had put a share link. Share link is a new thing added in iOS 16, which lets you use the built-in share UI activity controller. So you can use it like that. I had added it and for some reason it's making the preview crash. So I think Exo is trying to tell me that that's it. The live is over. I have covered everything I wanted. This is when I need to wrap things up. And you add it in the chat. Perfect. There is one question I want to answer. Which do you prefer, UIKit or SwiftUI? So from my point of view as a professional iOS developer, by professional, I mean someone that is paid by a company to work in the best interest of the company. I want to have a pragmatic approach, meaning that if SwiftUI can help me win time, I use it. If it doesn't, I don't use it. I don't want to have a dogmatic approach. So what we're doing at work is that when we have screens that are very simple, we use SwiftUI because it's much faster. When we are writing A/B testing experiments, so views that might go to the trash bin in 1 or 2 weeks if the experiment didn't work as we expected, we also use SwiftUI. But for parts where we need finer control, or what we want to achieve in SwiftUI is difficult or just not possible, we use UIKit. And it's a trend that I'm starting to see happening, where for what we could call the core use cases of your app, what is really like the core experience, what your app is all about, you use UIKit because you want a lot of control. But for the rest of the screens, like preferences, user account, that kind of thing, you use SwiftUI because it's not part of your core experience. So like for an app like Photoroom, the edition view, for instance, where you edit the image, it's in UIKit. Part of it is even made in Metal. But a lot of the other parts in the app that are more about forms, about basic UI screen that display lists or that kind of thing, they are made with SwiftUI. Okay, so I see a lot of people that are happy with the content of the stream. So thanks, super glad to see that you've enjoyed this new format. Will I continue to make this type of streams? Yes, I want to keep trying this type of streams. So building your first, writing your first, etc. I'm also going to make video versions for things that are a little bit more smaller, because I don't want to make 2 hours videos, because I don't want to edit a 2-hour video. But there will also be videos. If you have ideas for future videos or future streams, please feel free to let me know, like write it in the chat, write it in the comments, tell me on Twitter, but let me know. It's always super useful to have this kind of ideas, but I will be doing more of these streams, definitely. And what about cross-platform compatibility? So in this, SwiftUI is cross-platform compatible. Of course, there are always caveats, meaning that, for instance, on macOS, from what I understand, it can be a little bit harder to use. Actually, Apple has some tutorials on SwiftUI, and some of them talk about how to mutualize code between between iOS and macOS, and they do it quite well. So I can really encourage you to go check them out, because to get an introduction on the topic, I think they do a pretty great job. And I'm just checking. So as a conclusion, what did we cover in this live? So we saw how to create a new SwiftUI project in Xcode. We implemented a simple UI with mock data. So we talked about the text view and the modifier you can apply to it, the VStack and HStack modifier to be able to lay out data vertically and horizontally. There is also HStack to be able to stack pieces of UI on top of each other. We saw how to use a list and how to use the identifiable protocol. Then we made a network call. We used decodable to decode a JSON into a struct. We used the task modifier to implement an async call when a view appears. We saw the addState modifier to be able to redraw, update the UI when a piece of data changes in a view. We saw how to implement a loader. Then we talked about architecture by implementing a simple view model. We talked about what observable object and at observed object, at state object were. We talked about at published was, where it was super important not to forget these property wrappers, otherwise your UI won't update, basically. And let me tell you, it has happened to me recently to not understand why my UI didn't update, only to realize that I hadn't annotated a property in a view model with at published, and I had only lost like half an hour on it. So be on the lookout for it. It can happen faster than you think. We saw how to implement this state enum. So really, like, if there is one architecture point you should take away from this live, is the state enum and the fact that in the body of a view you can switch over the body, and it really opens a lot of possibilities in ways to split the code. And finally, we created a detail view. So in this detail view, we digged a little bit more into how lists work, and more specifically, we splitted the UI layout part of a list with the iterating over some pieces of data part of a list. We implemented a navigation with its data flow, because we are passing the movie from a parent view to a child view. So we've covered quite a few topics in this live. It's a discovery live, meaning that after following this live, you don't know how to make a real SwiftUI app that is production ready. However, my goal with this live was to help people who are learning, who want to learn SwiftUI, make the first steps on that big stair that is learning SwiftUI. And then, after what we've seen in the live, you can go check out articles, check more advanced tutorials, and normally you have the foundation to be able to understand them and not to struggle too much with them. So I see very, very good questions. So should you use and rely on SwiftUI when starting a new app from scratch? Overall, it is a future, and UIKit seems old, despite the fact that you can do more precisely with it. That's a great point, and it echoes like the statement that was made at WWDC last year. The best way to build an app is with Swift and with SwiftUI. The Swift part is pretty clear right now. SwiftUI, the first thing is that SwiftUI and UIKit are interoperable, meaning that when you create an app in SwiftUI, you can always put UIKit in it later. And the other way is true also. So you're not committing to something, you know, like it's a two-way door choice. Like you can always go back, always use UIKit if it makes sense. So I would say be pragmatic. Probably iOS developers are a bit more experienced. When they see the designs for an app, they can be like, okay, like this seems complex. Maybe UIKit will be needed there. But I would say, if you need to get started, if you are more comfortable with SwiftUI, start with SwiftUI, and when you hit a roadblock, then consider whether or not you should start using UIKit for the particular part that is like behind the wall that you've been like confronted to. Hope you see what I mean by that. Then for the retry button you've implemented, we need to set the state to loading again when loading the movies. Absolutely. I forgot to do it in the view model, but indeed you would want here, so at the very beginning of the method, to do state equal loading so that the loader reappears when you are reloading. That is a very good remark. And yeah, so people discussing, Wilfried is discussing whether or not to go in SwiftUI. Exactly, that's basically what I had said. Okay, yes, remember to click the like button, like and subscribe if you have liked this live. Also, share it around if you think it can be useful to other people. Honestly, sharing content is one of the best way to help a content creator. And last question, which is the best MVC, Viper, MVVM? Let me display so that people on the replay can see it. So I have never used Viper and I'm not a big fan of it because I feel like it adds a lot of boilerplate. That's why people have asked me for a video about Viper, but I don't know Viper. I cannot make a video about Viper. MVVM is the architecture I have the most used since like 2016. So I go a lot with MVVM. Honestly, I think it's a great way to do it. You can still do MVC mostly in UIKit because MVC doesn't work that well with SwiftUI, but in UIKit you can do MVC and split everything into child view controller. That's actually the way that Apple had kind of envisioned the pattern, from what I understand, and the way that they implement their own apps. So MVC can work, but MVVM, I think in the industry, it's at least from my personal experiences, is the one that I feel is the most widespread and is a good pragmatic way to deal with the problems that an app has to deal with. I feel like Viper is overkill in most cases, and MVVM is like at the right level. You know, like you don't want to over-engineer, you don't want to under-engineer. It feels at the right level. And so making large apps with SwiftUI, that's actually a big topic. Very hard to cover, but I would say top of my mind, learn about dependency injection. It's really like the big skill to be able to make things scale. Learn about how to split things in packages also. But yeah, like being able to inject the parts of your app and to split responsibilities, I feel like that's probably the thing I would start with. And yeah, implementing complex things. So that's something where this format of live stream could work very well. Also, the videos that are coming, like how to implement your first model in SwiftUI. I'm always trying to basically like there is a lot of content already out there. For instance, Paul Hudson from Hacking with Swift has made a lot of quality content. So if he already has some great content on it, I might not choose that topic because I feel like I won't be bringing a lot. So I try to cover topics that others have not covered. But yeah, I am keeping the idea in mind most definitely. Thanks for the suggestion. And I think this is when I will cut the live because it's already like 10:23 p.m. at home, and I'm starting to feel a bit tired and my throat is starting to kill me. But once again, thanks a lot for taking part of this live. Thanks a lot for all the messages in the chat. I think this is definitely the record of messages in the chat since I'm doing lives, and it really made this feel very alive, and it will also be very valuable for people watching the replay because they will be able to benefit from all the nice questions that you had and that I wouldn't have thought to answer or to cover the topic that you asked if there hadn't been this question. So big thank you for being part of this live and this replay. And all I have to say is, as always, thank you for watching, and see you next time. Bye-bye.